All right, so we started talking about Java last week, and there was actually 2 PowerPoints we were supposed to go through. We went through one of them. I know we had a little bit more difficulties with Eclipse than I first saw it. So we're a little bit behind, which is not a big deal. This course is quite organic. Sometimes we're ahead, sometimes we're behind. In the end, we do cover everything, so it's fine to slow down. So what we're going to do today is we're going to finish talking about Java basics, and then we're going to also finish writing the test case that we started last week, and then, go into more. Possibly start talking about locators, start talking about well, actually, before that, we'll talk about how to debug your code. So once you have a small test case, I'll show you how to set what we call breakpoints and how to, in Eclipse, go step by step through your code and actually see what's happening behind the scenes, right? Because it's nice when you press a button and everything just magically goes and it's done, right? But when there's a problem, fast is not your friend. You actually want to be able to slow down and go step at a time. So that's kind of part of what we're going to try to cover today, right? That's kind of our goal for today. All right, so Java basics. We talked about concepts. So there's some things we covered last week, like what is an interface, right, and why we need it. What are classes? What are instances? Why Java is called object-oriented programming language. So let's talk about some smaller details. Variables. What did we say last week? What is a variable? Don't look there. It's not interesting. What did we say last week that a variable is? It's a container, like a Tupperware in your refrigerator, right? Only it's a container that you cannot see inside, so you have to give it a name, right? It's kind of like if you have all the same containers and you want to remember what's inside each one of them, you give it a name while it's in the refrigerator. And when you're ready to take stuff out of it, you erase the name, right? So you recycle it. Make sense? So that's what variables are. And in Java, there's actually there's several variations of how you can declare a variable, right? But the 2 categories that are most distinct are there are instance variables and there are class variables. All right, what does that mean? Well, if something is an instance variable, it means that each time you create an object out of a class. Now remember, what did we say class was? What was a class? It's kind of like a blueprint of a house, right? And we can make many houses out of one blueprint. You guys remember that? All right, so think of an instance variable as a variable that belongs to the actual object that you make from the blueprint. Does that make sense? For example, the color of the house, right? So a color of the house is a variable. Make sense? And if you have a blueprint, you can make a yellow house and an orange house and a red house and a blue house, right? And with every single house, that variable will change. Does that make sense? Yeah? Okay. Now, a class variable is something that actually belongs with the blueprint. And it's kind of a weird concept to consider. The reason why I'm saying this is if this variable belongs to the class, it means that if on one of the objects created from that blueprint you change something, it actually affects all the other objects created from that blueprint. A little bit weird, right? But we actually do see it in real life. For example, a joint bank account, right? So a husband has a card, a wife has a card, right? And there's one variable, right? The amount of money that's in the account. That's the variable, right? It varies. It's a variable, right? So, the husband goes to work, earns the money, puts it on the card, right? And then, I go to shop and I spend. What happens to his bank balance on his card? It goes down, right? So even though he didn't do anything with the variable, right? He assigned a value to it. My actions had effect on what his card, is going to show. Does that make sense? Right? And that's because the account doesn't belong to the card. The cards belong to the account. Make sense? So if I change something, think of it as kind of the class variable is simply a link to the same value. From all the objects, it's just a link to the same value. That makes sense? And that value resides with the blueprint rather than residing with each object that has been made out of that blueprint. So far, so good? All right, so we can recognize these variables. You can tell apart the difference between an instance variable and a class variable, because on a class variable, you will have a word static. All right? So static. And oftentimes, when things are declared as static, they're also declared as final. So most of the times, you will see things like static final or final static. You can actually mix and match these words around, but usually people say final static and then, string. That makes sense? Now, what does final mean? Final means is that once you assign it, nothing can change it. All right? It's kind of like the amount of moons the Earth has, right? It's 1. It's final. It's a final count, right? One new moon is not going to just spring out of nowhere, one day be like, hey, right? So it's a final count of the amount of moons. Or, once you're born, again, I know there's all kinds of weirdnesses out there, but you have 1 head, right? That value is not going to change, right? You're not going to one day wake up and be like, whoa, 2 heads today. I'm having a good day, right? So that value for you is final. However, is the number of heads for you as a human, or for us as human beings, static? Is it static? Why is it not static? Do we all share the same 1 head? We all have our separate ones, right? So it means that while a value can be final, it doesn't have to be static, right? Similarly, just because the value is static, it doesn't have to be final, right? Maybe you actually want 2 objects to be able to change the same value as you run your code, right? I don't know, maybe you do. All right, so that's how you tell a class variable from an instance variable. If it says static in front, that means it belongs to the class. That means be very careful when you change it from your instances of that object, or instances of that class, instance of that class, because it will affect everything. All right? All right. There is also a different sub-level of variables, and that's basically their accessibility, I guess is the word we would use. There is a way to scope variables, the way to make them less visible to the outside world. Remember last week we talked about having some personal information that we don't want to share with everybody publicly, but we also have several categories of personal information, right? So things we will share with our, best friend or our parent or our husband, or things that we'll share with our, kind of maybe a small circle of friends, right? And then things that are just basically available to anybody who goes down the street and sees us, right? That's public information. Does that make sense? Right? So when we say that something is public, right? Public, it means that everybody who wants to can have access to it, right? It's public knowledge essentially, right? If we say something is private, right? Private, it essentially means that only we know about it. Like it's private, right? And then there's also this category of protected, right? When something is protected, it means that all of the files that live in the same package, the same folder essentially. You guys remember that packages are just folders? With us, essentially our siblings, they can access this information. They know this information. But nobody else can see it. Like even our parents can't see it, right? Parent cannot see it. So it's kind of a little weird and interesting. Similarly, I would actually have to check this. I think that when you inherit, you also get to have access to that information, but I'll have to get back to you on that. I know siblings for sure. I'll get back to you on the children, but I think children can also see protected information. There's also one more category, and that is when you don't put anything. All right? Actually, yes, children can see it too. Because when you don't put anything, when you don't put if a variable is public or private or protected, that creates a 4th category. It's a 4th category that most folks are not aware of, because it's, you would think that if you don't put nothing, it means it's a mistake, but it's not. That's actually when even your siblings can't access it, right? But if you inherit, your children can still see it. Make sense? Or if somebody inherits from you, I should say, not you inherit, but if somebody inherits from that object, then the children can see it. All right, this one is kind of not an enforced rule, right? There's no enforcement of this rule, but when you pick variable names, make sure they are self-descriptive. When, for example, you start learning a language, let's say you go to Foothill, right? For example, to learn Java. they'll have you comment all your code. They'll have you put in comments and comments and comments. What does this line do? What does that line do, right? They'll have you comment. That's called documenting code. But in real world, you will rarely see developers add that much comment to their code, right? Instead, what we usually will do is we'll give variables and functions self-descriptive names. So even when you're creating a function and the name seems pretty long, it's still better to have a name of the function that actually says to whoever's going to end up using it what it does, right? Because not a lot of people are actually going to go into your code and start reading all of your comments, except for docs. So when you create a function, it's possible to attach a little paragraph with documentation, right? And I'll show you what that looks like in a bit. But most of the time, folks prefer to just look at the name of the function and be able to guess what it does. So don't call things like G or EMP or like 3-letter abbreviation of something. Because honestly, even you 2 weeks later are not going to remember what on earth that function does. All right, so self-documenting code. But other than that, it is case sensitive. So if you have a function all lowercase and then you can have a function that is camel case. Do you guys know what camel case is? What is camel case? If you're dealing with a number that is larger than this, okay, I know I'm not thinking money anymore. I'm thinking more like science, right? And calculating DNA and where numbers go completely crazy out of the atmosphere. Then you might actually want to declare an object called number. If you want to store a number larger than this, there's actually an object for that. It's called number, like capital N, number. And you create an instance of it, and then you can store huge numbers in there that are much larger than this. And internally, what it does is it does this funny mechanism of splitting up a larger number into smaller numbers and like different weird multiplications and algorithms. So if you're ever in a situation where long is not enough, use the number object. Make sense? And we'll cover what that means later as well. All right. Now, if you're not using a whole number, right? The first 4 are just for whole numbers, and frankly, the first 2 you're not really going to be using anyway. All right. So the next 2 situations we're going to cover is decimals, right? Now, if you have a number that only has 1 digit after the decimal point, 1 digit after decimal point, you can use a float, all right? A float is a number with 1 digit after the decimal point. If you're going to store a number that has more than 1 digit after a decimal point, or you're calculating something where you actually want accuracy to be kept more than to 1 decimal point after the 0, then use a double, all right? And in all honesty, most of the time I just see people use a double. Again, it takes more space, right? More space, twice as much, but memory is cheap. So if in doubt, use a double. And not only that, it is so much more common now to just use a double that if you want to store something as a float and declare a variable as a float, you actually have to put an F. You have to concatenate an F to the value in order for the value to be stored as a float. Otherwise, your compiler, Java compiler, will actually assume, ooh, decimal, a double. That's kind of the default. If it sees a decimal, it's like, it's a double. So if you really want to force it to store it as a float, you actually have to say, no, F, float, right? So use a double. But if you ever see something with an F in front, you'll know it's a float, right? All right, Boolean. What's a Boolean? False. It's a true or false, right? And then, of course, we have the char or car or care, depending on how you want to say it. I say char. I know it's pronounced character, but there's no way I can read that as a char. It's a char. You can call it what you want, though. Honestly, there's no wrong. It's tomato. Okay. Now notice how I didn't say anything about long words, right? On the previous screen, I talked about 1 letter. Right? And you store it as a char. But what if you want to store multiple letters, right? Well, in Java, there's actually another data type, and it's called a string. But a string is not a basic data type. It's actually an object. An object that uses a combination of characters to store your words. Make sense? And that's why before we talk about strings, we're going to talk about arrays, because strings are actually they're built on top of arrays. They're very complex mechanism of arrays and characters. Does that make sense? So let's talk about arrays before we talk about words. All right, arrays. Arrays are kind of like bookshelves. Essentially, that's how you can think of them. All right? Now, you know how when you look at a bookshelf, It's very rigid. It's kind of all the same. All the shelves are the same. Well, okay, I know they have some fancy, weird bookshelves, but we're gonna talk about a basic one, the one you get at IKEA. It's basic, or Target. I don't know. So when you declare an array in Java, it means that all the things you store inside are the same. You can't have like, I don't know, an elephant on one shelf and an apple on the next, and then I don't know, a penny on the third one, and you cannot, no mix and match. If it's a bookshelf for books, there's books in every shelf. If it's if it's shelves for, I don't know, Tupperware, there's Tupperware in every shelf. Does that make sense? So similarly as with declaring variables and regular, basic variables, before you declare an array, you have to know what goes inside, right? So you can declare an array by putting square brackets in front of the variable. Right? So see how there's square brackets over here? But before you put square brackets, you also have to specify what kind of data is going to be inside each one of those shelves. Right? So what do you think is being stored in here? Integers. Every shelf in that array, right, is going to be an integer. What if I put a float in front here? What am I storing in every single shelf? A float, right. A decimal, exactly. What would I have to put here if I say true or false? Good. Now, arrays are kind of weird. There are two ways to assign values to an array. Declaring is always the same. This is what the declaring of a variable to store an array will look like, right? This top part. But there are two ways to assign a value to an array. You can declare it empty and then fill it up. Or you can immediately say, well, all this stuff has to go in there, right? And then your array will figure out how big it needs to be. Make sense? But once you either immediately fill it up and the array kind of, sets its own size, or you set the size before filling it up, once you set the size, one way or another, arrays cannot extend or shrink. So that means that if you declare an array of 10, even if you put just one value in there, it's still going to hold 10 spaces. All right? Similarly, if you have 10, you cannot shove an extra one in there. All right? You cannot be like, oh, we only have 10 shelves. Let me put something into the 11th shelf. That doesn't work. So if you try to put something into the space 11, even when there's only 10 shelves, you will get a compilation error. Essentially, it means that you will not even be able to compile your code, much less run it. So no running for you. Your test will not even try to run. It will scream bloody murder and just, no. So be careful with that, because that's, I think, the most common issue when we just start writing code, that we kind of forget, wait, it's called actually a problem of one. Lots of people refer to it as a problem of one. Lots of times, most of us, when we write code, will be off by just that one, right? Like one more or one less than we need, and then we'll have compilation errors. All right. So, yeah. Yeah.
You said it won't work if you put an extra one, but if you put in less than what's assigned, will it still work?
Yeah. I mean, so if you have 10 shelves, right, you can always take something from the 7th shelf or put something into the 6th shelf. Does that make sense? I mean, you'll be replacing whatever is there right now. If it's nothing, then you'll be, replacing nothing. But it's fine. It will still compile. It will still run. That's okay. But if you say, oh, well, all my 10 spaces are full, let me one more. Yeah, not going to happen.
So it should be always integer?
No. This is just, this specific array was for an integer, right?
Okay,
but it's like we said right now, you can put anything you want in front of it. Okay, so in this case, right here on the bottom, what we're doing is we are declaring a variable, an array, right? And then on the next line, we are setting a value to it. Or I'm sorry, setting a length to it, not a value. We're setting the length for it, right? So we're saying, all right, I want to create a Tupperware container for my array, right? By the way, what is this container called? We have this little bit of lettering here. Can you read this for me? What is this container called? An array, right. So this is the actual name. This is how you will refer to that container, right? And this is the type of container it is. It's not a regular Tupperware container. It's one of those fancy bento boxes that has all the little compartments inside, all right? It's a fancy container. And you know it's fancy because it has the square brackets. It's telling you that I have subsections inside. That makes sense? And in this case, what kind of bento box is it? It's an integer. It's a bento boxes with little integers inside, right? So there's going to be a number inside every single container. That makes sense? Is everyone hungry now? All right. And over here on the next line, what we're saying is, well, this was just a container, but we weren't actually storing anything inside, right? Here, on the other hand, we're saying, now I want to allocate 10 spaces, right? That's what I'm doing here. I'm saying I want to create new storage, new 10 spaces. Make sense? Now, on this line, instead of this, I could have just as easily put square brackets and then just said 1, 2, 3, 4, and then just wrote out all the 10 numbers. And it would have then said, oh, you listed 10 numbers. All right, that means you want a length of 10. Does that make sense?
Yeah.
I mean, it doesn't have to be 1, 2, 3, by the way. It can be like 2, 4, 6, or, 3, 6, 9, whatever you want it to be. Or randomly.
Every shelf is, in the example you have here, is just for 1 digit for shelf. So it has to be just 1 digit.
Yes. Each one of these little containers will contain one number.
So you have 11, it goes back to 0, 1.
We'll talk about this in a second. Let me just finish one last thought. So, by the way, you don't have to do this in 2 lines. You could have just as easily done it in 1 line. In other words, you could say this, and then right next to it say equals new int 10. That makes sense? So you can cut out the middleman and just continue on this way. That makes sense? Yes?
Why do you have to say new?
So an array is actually also a type of object in Java. And so when you are creating a new object, that's how you specify that you're doing it. You're saying, I want something new. And then Java will actually allocate memory for that new thing it's about to be born. So it's just kind of a little keyword that specifies, I had a description and now I want to make something out of it. All right, so I was asked about these numbers on top, right? Very good question. So when you have a bookshelf in real life, right, and you're talking to somebody, maybe like you're in this room and your son or daughter are like, Mom, where are my books for school? You can say, look on the first shelf, right? Or look on the 6th shelf, right? That's how you usually say. Well, in computer speak, the first shelf is actually 0, right? So that's why when you look in here, it starts with a 0. This basically just specifies to your calling function or whoever is calling you, right? Not your child, but in the real computer world, which shelf to look at, essentially. That's how you say, I want to look on shelf 7, which will actually be which shelf? 8, right? If it's 7 and we started with 0, right. So see how this one says 7, but it's 1, 2, 3, 4, 5, 6, 7, 8. Does that make sense? So it's a little bit confusing. That's again where that issue of 1 comes in, right? Where you're like, it's a 7th shelf, but I need to put 8, or I'm sorry, I need to put 6. Right? It's a little weird. So just remember that you start from 0, and that means you kind of have to add 1 more in your head if you want to get something, or subtract, depending on which way you're going.
Wait, so can you change that number after you assign the value?
This is not what is stored inside. What is being stored inside is this. This is kind of like your mailbox, right? No matter what you put inside your mailbox, the number of your mailbox will stay the same, right? So, I can't think of another example right now, but yeah. So when you create an array, the numbers for each little cell are always going to start with 0 and go outwards, 1 at a time. It's never going to be like 0, 3, 29, 62. No, it's always going to be 0, 1, 2, 3, 4, 5, 6, 7 into infinity. Make sense? All right. Yeah, so that's what I was saying. I'm sorry, I said square brackets, but curly brackets is what I should have said. So yeah, if you don't want to declare in advance just empty space to eventually house your numbers, if you already know what's going to be housed inside, then this is how you assign values immediately. Yes?
For the float with the decimals, you would assign
Using a decimal point or just this
You
time?
definitely would have a decimal point, but the problem is when you say numbers like 2.5 in Java, they're immediately assumed by the compiler to be a double. And so if you have a float variable, like you actually said float my number, right? And then you say equals 2.5, your compiler will actually say that you have an error. Isn't that weird? Because even though you said 2.5, and 0.5 is just one number after the point, right? So technically it is a float, right? Your compiler will assume that any number with a point is a double. So if you want to store it as a float, you actually have to have an F.
But if it's a double, then we declare its value as
Double.
2.55. That would be it.
You could also do 2.5. You could also even do 2. It will be stored as 2.0. Yeah.
Really?
Yes.
How to declare dynamic array?
That's what's essentially lists or strings are dynamic arrays.
It's
But
list a dictionary too?
a dictionary is not actually an array. It's more of a,
But you can use list.
you could use a list. That's what lists are for. Yeah. And lists are actually, there's subcategories of lists. There's array lists, there's just this, all these, there's sets, there's,
Maps.
hmm?
Maps.
There's maps, there's queues, there's, I'm blanking out right now, but there's all these different types, essentially, that have their own rules. But they all fall under the list interface. Yes?
For dynamic memory allocation, can we use malloc and killoc? For dynamic memory allocation, can we use malloc, killoc, those functions or?
No, they belong to C or C++.
Yeah, they're made for C, C++, but for.
I'm not sure what you're trying to do in that case. I think I'll need an example
Java
to tell you what
doesn't
you would
have
actually
it.
do.
Try to work with memory.
Can you
Dynamic memory allocation.
No, I understand, but can you give me an example? Like, what are you trying to store? What is the situation? Because I think you would be fine with just a list in this case.
Anything when we want to allocate memory during runtime.
I don't, I mean, I think in your case, you're talking about buffers. That's the only time I can think of, like, a reason you would need memory but not fill it up with something, or you want it ahead of time.
Right now we allocated 10 spaces for array, right?
Right.
But I don't want to allocate 10 spaces. I want to allocate whenever I'm running the program, depending upon my input, I want to allocate the memory during runtime.
Well, that's what I'm saying. It really depends on the situation, what kind of data type you're going to use.
Yeah, so like
Lists
how
are
many,
dynamic.
what
Strings are
functions-
dynamic. But there's also all these other things. There's hashes, they're dynamic. There's buffers, they're dynamic. So there's all these other things that you can use, but it really just depends on the situation. Java is one of those things that there is no catch-all. It's very tailored to each single situation. Does that make sense?
Yeah.
Versus like if you were doing Python, in Python every variable is dynamic. I mean, you declare, a variable, you store a teaspoon inside it, you take it out, you stick a house in, it doesn't matter. It shrinks and expands. But in Java, every situation, even dynamic memory, is very contextual.
No, for example, in C, C++, we use malloc and killoc functions.
No, I think in Java,
Static.
they will decide.
Oh, okay.
I understand what you're saying, and I think
So
in your
there's no
case,
static
for
file,
things
like
like
there's no
that,
fixed
like if
file.
you're reading from a file and you don't know how much memory is coming, stuff is coming in, you would use a buffer. That's why I'm saying that. That's the only situation I can think of that you might be asking about. Like, I'm sure there's more complex ones, but I can't think of anything right now. Okay. Again, we always have to say in Java. Other languages are different, but in Java, if you're comparing non-objects, and strings are objects, you guys remember that, right? Then you can use the following comparisons, right? So you can use equals. By the way, keep close watch to this. There's 2 equal signs here, right? If you put just 1 equal sign, it's kind of weird because your code will still compile. So for example, if you say something like, does 2 equal, does y equal 2, right? You're asking a question. But if you put only 1 equal sign, what you're essentially doing is you're assigning 2 to y, and it will still come back as true. Does that make sense? So every time you assign something, if you're able to successfully assign it, your code kind of also returns a true, even though it's not explicit. So your comparison will still compile, and it will still be fine, just your code will be broken. It will always come back as true and it always run. And you'll be like, why? I know y is 3. I'm looking at it. It's definitely 3. It's not 2. But it will actually reassign that y to 2 while you're doing that comparison. So be very careful with equals. There's 2 of them. All right? And then everything else is kind of self-explanatory, less than, more than, less than or equals, more than equals, right? All of us know that. The only one to also point out is the not equals. You say not by putting an exclamation mark. That's what it means in computer speak. You can actually use exclamation mark with binary bitwise comparisons as well, but it's not really a common thing, so I don't expect you to have to run into it. However, for strings that are objects, right? They're objects. You cannot use equals equals or not equals. You actually have to use built-in functions. So for strings, there's actually, the actual string object comes with its own comparisons. So if you want to compare 2 strings, you have to say equals or compare to. All right? So far, so good? So when you say equals, it literally has to be the same value inside both strings. Right? So for example, lowercase apple and lowercase apple. It cannot be uppercase letter and lowercase apple. Right? Those are not equal. They have to be case identical. Make sense? Versus compare to, it will alphabetize them. So if you're comparing A and B, right? A is alphabetically what? Less than B, right? So it will actually come back and say, yes, B is greater than A, so it will give you back a 1, right? But if you compare B and A, so you basically reverse the order, right? B is alphabetically greater, right? So it will tell you -1. It's basically going to say that you're in the opposite direction, right? And if they're exactly the same, I'm sorry about that. If they're exactly the same, like A and A, it will just give you a 0. So essentially, it's always more than 0, 0, less than 0, and 0, if they're exactly identical. Yeah. It doesn't actually have to be -1 and 1. I didn't want to put the wrong impression in. It can be like -63 or +2. It just depends on what it calculates. Okay, here's how it works. It takes the 2 strings, converts them into some kind of weird number, and then compares them and sees if they're alphabetically the same. So it gives you back a weird number. But what you essentially want to know is if it's less than 0, more than 0, or 0. It's frozen again. You guys can't see it, huh? There's a beach ball of death on my laptop. You guys know what a beach ball of death is? No? If you've ever had a Mac, it's like this like happy-looking ball that's rainbowish, and it just circles around, and your computer is frozen. It's wonderful. It's called beach ball of death.
Restart your computer.
Do you see it now? Beach ball of death.
Start to use Windows.
In Windows, like, I don't know, 6 or 5, they have this standard. What was it called?
You know what? I used to be such a fangirl of Windows. I used to be like, Windows all the way, Macs suck, I'm not gonna touch this Mac thing at all. And then I had to work with testing mobile iOS devices. And you kind of can't do that without a Mac. And now I kind of fell in love with it. I'm like, I don't feel comfortable on Windows anymore. Like, the trackpad is not as responsive. It annoys me that I can't do everything from command line because I'm just so used to having access to Bash and Linux easily without having to run any kind of additional stuff. You can curl, you can see SSH into anything you want. Versus in Windows, you have to download PuTTY and you have to do all these other additional applications. So it's just kind of like what you're comfortable with, I guess. For a developer, I know this sounds horrible and I'm totally betraying Windows, but for a developer, Macs really are better just because you have more access to command line options. Like, for example, changing permissions on a file is so much easier on a Mac. It's one line than it is in Windows. Setting environment variables. In the Windows, you have to click like 6 different options. On a Mac, you just say export the name of the variable and the value. Ta-da! You're done. So, sorry you guys, yeah. Windows is great, but on the other hand, if you're going to be writing like C# or C++, you probably want to use the Windows because kind of Microsoft babies, so. It is what it is. What am I gonna do with this PowerPoint, huh? I don't understand why it's flipping out on me. It's really weird. Okay, I think you know what we're gonna do. I know. I don't want to do that either. Okay, we'll just bear with it. I don't know what's happening. All right. So far everything makes sense, right? Right? So far everything's somewhat easy. It's somewhat easy. By the way, I'm definitely not teaching you all of Java. People spend years learning Java. So what you're gonna learn in like 2 lessons here is like what you need to survive to write one basic test, right? And then if you're gonna go into this field, please hear this, okay? If you're gonna go in this field, you must independently learn the language, all right? And if you're not gonna go into this field using Java, then learn a different language, but you must learn a language on your own. What I'm gonna give you in this class is like a drop in the ocean, all right? Now, on that note, when we're talking about Java, it's huge, and there is no one person that knows all of Java. It's not possible to learn all of Java. So people get specialized, right? People specialize in different sections of Java, like maybe, you know, front-end Java, where you do UI, and back-end Java, or, you know, or like, you know, databasing, and then, you know, streaming, and media Java, something like that, right? So people specialize. So if you know what area you're going to be in, specialize. But you do have to do it on your own. Definitely what you're going to learn today is not enough to consider yourself a programmer in Java. On that note, however, once you learn the syntax, most programming languages are not about complexity of code, but rather the logic. Like, I'll later on ask you a question, and it has nothing to do with code at all. Can you logic it out? You need to be able to logic things out. I think that's the difficult part. Okay, loops. When you want to do something multiple times, right? That's when you create a loop. There's actually 2 different types of loops. There are while loops and for loops, but for loops are definitely much more common. How do you decide when to use a for loop and when to use a while loop? I know we're not talking about while loops here, but here's the information anyway. All right, when you know specifically how many times you want to run something, or when you can calculate out of the data given how many times to run something. For example, I'm creating a function, and somebody is going to give me a list of data, and I want to print out every single value on the screen. Can I figure out how many times to run? When somebody gives me a list or an array, I can actually ask it, how long are you? And therefore, I do know, even though I don't know ahead of time, I can ask it once I get it, right? But if something is time-based, for example, I need to run something until it turns purple, and I don't know how long it's going to take to turn purple, right? Or I'm at a traffic light. I need to pause my car until green light, right? I don't know how long it's going to take until the green light. I have no idea. Oh, okay, fine. People told me lately that apparently in India, they have traffic lights that actually count down until you have a green light. Awesome. I've been to Moscow like during this week, and they have traffic lights that count down, and I'm like, wow, this is like the best thing since ever. So yeah, there are situations in other countries where you know how long until green light. But in US, what do? You sit in your car and you go, still red. Oh, still red. Oh, still red. Oh, still red. Right? So that's a while loop. You don't know how many times you have to look up. Each time you're bound to get a little disappointed until finally it's green. Make sense? That's a while loop. It's time-based. You don't know. But if it's anything but time-based, chances are a for loop will be fine for you. You can use a for loop. Okay, now, on that note, there are 2 ways to declare a for loop in Java. This one, the one we're looking at right now, is the new Java for loop, all right? And this is more similar to things like Ruby and Python, all right? They're meant to mimic those languages. So it's a more simple way to declare it, but there is some kind of flaws to it, or downfalls to it as well, all right? So it's easy. You declare a variable to hold one item out of your list. Now, when I say a list, I'm talking about lists and also arrays. Basically, I'm talking about anything that holds more than one value. That makes sense? Anything that it is enumerable, right? Or you can iterate through it. Make sense? So all you do is you say for, and then in parentheses, you're gonna specify two things. You're gonna specify a temporary holder, so it's temporary variable that can hold one value from this list each time. Now let's play a game. If my list has all integers, what kind of holder will I need? An integer. All right. If my list contains elephants, what kind of holder do I need? An elephant. All right. So you guys get it, right? All right. So that's what happens here. This is the most basic one. So let's look at the code. We have declared, what did we declare? Is it an integer or an array of integers? We declared an array of integers called numbers. And we stuffed numbers from 1 to 10 inside, right? So how long is this array? 9, 10, 11, 10, 9. Let's pick one. 10, right. We didn't start from 0, but there are 10 numbers from 1 to 10, right? Now, what is going to be the length of this array then? 10. What is going to be the index, or rather the number of the first container? Previous screen, we talked about this less than, more than, equals, equals, not equals. It's a question. Now, it doesn't always have to say less than. It could say more than. It could say less than or equals, more than and equals, not equals. All right? It can be anything you want, any kind of question. It could even be a Boolean, like, are you an elephant? I don't know why I'm talking about elephants today, but apparently that's the word of the day. All right? Does that make sense? It can be any kind of question, right? It can be a true or false question, but it's a question that has to return a Boolean. All right? And then based on what this question returns, that's how your loop knows to keep going or to stop. If this becomes false, we stop. We don't go anymore, right? We go to the end of the loop and we keep going with whatever's after the loop. Make sense? All right, now what's happening here? What is this plus plus business?
Plus 1.
Plus 1. Right. Now, who's heard of C++? Do you know that there used to be a language called A, and it kind of sucked, and then B, and kind of sucked, and then they came out with C? Everybody heard of C, right? All right, so C actually was the one that succeeded, and then the developers after that who created C++, they were like, we're geeky, we're gonna make a joke, C++, instead of calling it D. So that's actually what happens, true story. Now, what is here during the loop? What are we getting inside here? No, I mean, what kind of code? What is accessible inside that loop?
Loop.
This is the for loop. This is the code that's going to be repeated. But in the previous loop, we had our list, and we had each time through the loop an item from that list. What happens here? Do we have a list? Do we have an item from the list? No. So what is the only thing we actually have inside this loop? I. It's the only thing we have. So if you actually want to take things out of a list, one item at a time, using this notation, you have to manually do it. All right? Now let's learn how to manually do it. Perfect. So I have an integer array called my array, right? So far so good? And inside it, it has stuff.
You mean manual I equal I plus 1? You mean manual I equal
No,
I plus
how
1?
do we manually? So remember before the loop, before the previous example, the for loop, we didn't have to take things out of the list, right? It was automatically supplied to us. But we didn't know if it was the first one or the sixth one or the last one. We didn't know. Here, all we have is I. That's all we have. But because we have I, we can actually figure out if it's the first one or the sixth one, because I is actually going to keep track. But now, how do we actually get the stuff out of the array, right? Before it was manually automatically given to us, but now we have to manually take it out. So how do we take it out? If we have this, how do I take one item out of here each time through the loop? Right, so you're gonna give the number of your array, correct? You're gonna say my array, and then you're gonna put set of square brackets, and this is basically you saying look at shelf, right? Look at shelf. And then here, instead of putting what you usually would do, first shelf, right? Or sixth shelf, right? Does everybody understand why I'm saying 6 and writing 5?
Yeah.
Okay, good. What would you do?
Why?
You would put an I.
I shall.
I shelf. And then each time through the loop, a new shelf would be looked at. Because I would keep changing. Now, next question. Does it always have to be plus plus? No. What if I want to increment by 2? How would I do that? I,
Plus 2.
well,
I plus.
think about it. We can't just do plus 2. We also have to save it back into I. So I plus plus is a very special beast. What I plus plus actually stands for is I equals I plus 1. That's what it actually stands for. Now, if you're thinking like, you know, what is it, 4th grade math, this statement makes no sense. But this is programming. And the I doesn't mean a specific one determined value. It's just a container. So what we're saying is we're saying take the value inside the container, add 1, store it back into the container. Right? That's what this code means. I is not like, what do you call it? I know in Russian, I don't know in English. Переменная.
Dimension.
Transition.
Dimension.
Yeah, not really even a dimension, right? So it's
Variable.
I don't want to use the word variable. That's the whole
I think
point.
that's what they use in math though.
Yeah?
Variable.
Okay, it's not that type of variable. Let's put it this way. It's a different. So
Counter.
kind of right.
Oh,
It's a-
variable or dimension?
Yeah, let's use that word because I don't want to use the word variable. So yeah, it's a container essentially. Okay, you guys get the point. So if I plus plus means this, and I want to not increment by 1, but I want to increment by 2, what would I do?
I plus equal to 2.
Yeah. So you could do this, right? Now we can talk about shortcuts in a second, but you're right. If I throw too much out there, it's going to be like, "Ah." Okay, so far so good? Now, let's,
Ellie, it's a classical style. You want to see how it's sharp. In one, no. You can how to use it I plus 2 and this one and first one.
no,
No way.
I'm just asking a question of, like, if you want to increment by more than 1, what would you do? That was essentially the question. Right? So, if you want to, hold on, let
Just
me
sign
just,
a different number.
what if you, all right, let's do this. Let's practice something else. Everybody remembers this, right? It's 2, 4, 6 instead. What if I want to print out every other number? Well, yeah, let's do that. What if I want to print out every other value? Every other. So, print, not print. Print, not print. Right? So far, so good?
Print I plus.
How would I have to set up my loop? What kind of for loop notation would I use? The first one or the second one? The classical or the new one? Which one?
Plus.
The classical. Okay. So I would say for, and again, I remember I have my array, right? I have my array somewhere out there in space. So for, I like purple, but it's not visible at all. So for, and then we have our parentheses, right? And then we have our code, and then we're gonna have system dot out dot print. Actually, it doesn't have to be print line. It can just be print, but sure, let's do print line. And then we're gonna print something here, right? All right. So I want to print out every other one. What do I do?
This is the second one.
I plus 2.
All right. So first thing people are saying is, those are my semicolons, by the way. Well, let's do this. They look weird, right? Okay, fine. That looks even worse. There. I'll be good. Okay. So I plus 2,
Equals I equal to I plus 2.
I equals I plus 2. Yeah? All right, what goes inside here?
So I equal to 1 and
I equal 1,
I
less
zero.
than 10.
I
Equals 0.
equals what?
1.
0.
So
It depends.
no, I said I want to print the first one, not print the second one, print the third one, not print the fourth one, print the fifth one, not print the sixth one. 0, right? If I said it backwards, if I said I want to print the second one, the fourth one, the sixth one, then I would start with 1. But because I want to print the first one, not the second one, I actually want to start with 0. Exactly. All right, so far so good. What goes in the middle?
The condition.
What's the condition?
Until what number?
Less than 11.
Length of the array.
Till this next one.
Yes.
Less than
I less than.
My array dot length.
Can I just randomly pick a number? 50 sounds like a good number.
Until len of array.
Yes. So we haven't talked about how to do it specifically, but I told you we can ask an array and a list their length, right? That's what I told you earlier. I didn't tell you yet how, but I did mention it, right? So when we are printing things out from a list or an array, we can't just randomly pick a number. Why not? Why can't I pick 50? 50 sounds like a great number to me. Why not? Because we don't what? Who's gonna stop me? Who's gonna stop me? It's not gonna complete the loop. The compiler is gonna stop me, right? That's what's gonna stop me. Runtime error is what's going to stop me. So yes, you cannot just say I less than any arbitrary number, right? You would have to find out the length of my array and use that. Now, how do you find out the length of an array? Easy. My array dot length. All right? Now, no parentheses. You don't need parentheses at the end. It's not a function. It's a property. It's like the color of the house. All right? So if you want to find out the length of an array, it's just the name of the array. Doesn't have to be my array. What if the name of my array is alphabet? Then it's alphabet dot length. Does that make sense? So you're going to say the name of the array dot length, right? And you can store that into some kind of variable, I don't know, len. And then you would say I less than len. So far so good? Now, you have to do that? No, you can actually take this entire expression and put it here.
Don't you, like, when you get the length back, don't you have to go one more? Like, if you have 10, you would have to say less than 11? So
No. So the length is actually how many items are inside an array. What you're thinking is actually one less. Like, you cannot go up to 10. Make sense? So like, I cannot say my array give me a number at shelf 10. Because if there are only 10 values in there, what's the number of the last shelf? 9. But what is protecting us? The less than. Now, if for whatever reason I did this, ooh, fail. Well, not fail. Crash. What's the difference between a fail and a crash?
Crash stops. Fail, you can continue.
Fail, it's not started.
No, a fail is actually something that we assert. Like it's part of a test that we actually test. That's when it's going to say fail. But an error is the crash, right? So an exception or an error is when things just went crazy. A failure is something you caused yourself. It's not there's something bad with your code. It's that the input didn't match the expected value. And you said stop the test yourself. It's expected. Like you were like, if it doesn't match, I want to see a failure. You're the one who asked for it. And an error or an exception, depending, I guess, on which language you're using, is when you didn't ask for it and you weren't even expecting it. You were like, oh shoot, right? That's the difference. All right, are we cool with this? Yes, we're good. All right. See, that's why I was looking at it really funny. I'm like, oh, what kind of example can I come up with? But this works out. Oh yeah, sorry, no, we're not done. What goes in there? What goes in there?
My array of I.
Hello, I.
Hello, I. Well, we don't really have a hello, but
Hello world.
Hello world.
My area of
I.
my area of
Oh, he wants to put hello world. Let's do that. Let's put hello. I don't want to type in world in here. All right.
It's typical example
Hello.
in coding.
And then yes. So then in coding, there's a big joke that the first program you write has to say hello world. Okay. And then what goes here?
Hi.
So each time we will say like hello 1, hello 3, hello 5.
Not I. Not I.
my area of
My area.
Oh yes, thank you. Sorry, you're right. You're right. Ah, I knew that. I promise. Thank you. Good eyes. See, good QAs in the room. Yeah. By the way, you guys, as I talk, I lose sometimes my thought process, so I will make mistakes, and it's your job to find my bugs. Okay? That's what we're here for. So find the bug.
Ellie, I have one question.
Yeah.
So in this enhanced for, if I would run a debug, if I run it as in the debug mode, and I'm seeing the value, and every time I like step into, I go to the loop, then I can see the value, right? Like each time it is.
What's inside? You can see what's inside the eye.
Yeah. Like
Each
something-
time, yes. Each time it will change through the loop.
Each time.
We're actually going to try that later today. So we will experience what it looks like. Not a problem. Okay, so far everyone is good? Is anybody's brain fried yet? No, we're good? All right. Let's talk about objects. I'm sorry. My bad. Let's talk about objects. So we now understand what classes are, and we understand what objects are, right? What's the relationship there? Objects are class. Objects are made out of classes or instantiated from classes, right? Make sense? All right. So there are 3 steps to creating an object out of a class. You declare it. Technically you, oh yeah, I guess. This kind of happens together, so I can't really say it happens one after the other, but you instantiate it and initialize it at the same time. That will make more sense in a second. Well, no, I guess it actually should be backwards. You declare it, then you instantialize it, and then you initiate the variable. I'm being very, very like picky right now with my wording, but we'll get to it. So, what is declare? Just like we were declaring a variable for an int, we would have to declare a holder for whatever the future object will be, right? Do we have to declare a holder? Can we just create an object and not have a holder for it? It's a trick question.
We can, but what for? We can, but what for?
Good question. Can you answer your own question? Well, first of all, let's we can.
We can.
Yes, we can. Why, right? What for? Well, if you're sending it to a different function as a parameter, like a function needs to have 2 things, for example, right? It needs to have a number and an object, for example, a fruit, right? It takes 2 parameters. You don't actually have to create a new instance of that fruit, put it into a variable, and then put a variable into the function, right? You can create a new instance of the object right inside the function call. What does that mean? It means that if I have a function called print name, for example, right? I have a function called print name. So far, so good? This function, it takes an object called person. Let's do it this way. No, let's do an object type person called it's called man. All right? So far, so good? Well, if I call this function, by the way, it's going to be something like public, and then void, right? So far so good? So we have this function, all right? It's public, means you can call it. Void means it doesn't return anything. It's called print name, and it takes a parameter, person. All right, so far so good? And there's stuff inside, all right? Now what it does inside is it says man, it says system dot out dot print line man dot name. So far so good? That's what it does. This function takes an object as a parameter. Yes? Now, when I'm calling this function, right, when I'm calling it, what I would do is I would say print name, right? And then here I would supply the input. Now, if I already have some variable, right? If I already have some variable that stores a person inside, I could say first, right? So far so good? But what if I don't? What if I actually need to create a new one right now? I need to create a new one right now. I would have to declare a holder for it, right? And do the whole initialization and instantiation. Instantiation and initialization, right? I would have to do it. But if I don't want to create that extra variable for it, right? Before putting it here, because why, right? I only have this variable until I stick it inside here. Does that make sense? Why create an extra variable? I could do it immediately inside the parentheses. So far, so good? So we'll come back to this example. So no, I do not need to declare a holder for it if I'm going to immediately send it into a function. Because that function will catch it into a pre-declared parameter. It already has a pre-declared holder for it. Does that make sense? So yes, you can definitely go without declaring. So far, so good? All right, now, initialization and instantiation. Instantiation is when you create an instance. That's what the word stands for. Instantiation, make sense? You create an instance. And this is basically a very fancy way of referring to that keyword we said earlier, new. So the whole instantiation happens when you say new. So far, so good? That's it. There's nothing else you really need to do. Now, when you instantiate something and you say new, you can't just expect magic to happen. Some objects, they don't require anything, and it will be magic. But some objects, they actually require you to first provide input. All right? So for example, you want to create a new tree, right? So we have this class called tree, and you want to create a new instance of a tree. A Christmas tree, or what kind of tree you want to make, I don't know, right? A tree. What do you need in order to create a tree? Is it just magically you say, let tree appear, and it appears? In the real world, what do? You need earth, you need water, you need a seed, you need time, right? All these things. Well, you would have to supply them into the function. You would have to say, I want to create a new tree. Here is the seed and the water and the earth. Make sense? And sometimes you have situations like, I can't even think of something where it just falls out of the sky. When something is for free, I don't know. Like even the lottery, right? You have to go and buy a ticket. Like you can't, I can't think of something. Oh, I know. A cold, a common cold. One day you wake up and there it is. So yeah, that's when you don't need to provide any input. Somebody else already did it for you and it's not a happy situation. All right, declaration. You guys, I'm trying to make you laugh because apparently laughter helps you remember things. So hopefully it's working. Are you remembering things? All right, so let's say that I want to create a new bicycle for my kid right? So I have a kid, a little Johnny. Okay, I don't have a Johnny, but I have a little Johnny, and I want to create a bicycle for him, right? Now, what kind of bicycle does Johnny want? He wants a blue bike, right? So from now on, this new bicycle I'm gonna get him, I'm gonna refer to it as blue bike. But blue bike is what? What kind of bike is it?
Blue.
It's a bicycle bike. It's not a motorcycle bike, right? It's not a dirt racing bike. It's a bicycle bike. So far so good? So I'm declaring a variable blue bike, and I'm assigning what type of data is going to be inside. Now, here's the magic. This is not real world. In the real world, in order to create a new instance of a bicycle, things will go inside it. But this is the magic world of programming, where you don't need to provide money or metal or rubber or anything else that goes into a bicycle. You just say, let it appear, new, and ta-da, bicycle. So here's what's happening here. You say new, and again, you repeat the word bicycle. Because remember, on the left side is actually the variable. And on the right side is you giving birth to the object. Does that make sense? So maybe you made a mistake and you said, I don't know, airplane, blue bike, right? If then on the right side you say new bicycle, is it going to work? No. The left side and the right side have to match, right? On the left side, you are stating what's going to be stored. On the right side, you are actually creating the object. Make sense? So that's why when you write it all out, sometimes it looks weird. Because lots of times developers will do something like this. They'll say, what are we doing here? They'll say bicycle, and then they'll actually say bicycle. And they'll say equals new bicycle. And then somebody like me comes along and says, right? But if you think about it, right? This side is just a poor naming of a variable, right? And Java is case sensitive. So as far as Java is concerned, lowercase b is very different than uppercase b. So you're allowed to do that, right? So all they did was basically they declared a variable of this data type, and then they created an object of that data type. That actually makes sense, right? And then they just picked a poor name that happens to be exactly the same except for one letter as the object, or an object data type. So far so good? If they just need a little bit more of a, what did we say that? Blue bike? Bike? If we just made a little bit more of an effort to pick a different variable name, it wouldn't be so shocking. So far so good? Right? So when you see something like this, like something equals new something, and it's the same three, the word is repeated 3 times. Just poor variable name, all right? Left side and right side is the data type, in the middle is just the variable name. All right. Now, this is where instantiation occurs, specifically here, all right? Where is the initialization happening? Initiation? Initialization. Initialization. Where specifically is it happening? Is it happening here? Is it here? Is it here? So all these fancy things that I'm right? But it's actually just this is the initiation. Initiation stands for initial value. All right? So when previously on the page we declared bicycle, blue bike, there was no memory associated with it. There was no value associated with it. It was just kind of like, here's a Tupperware container that we're later going to fill, right? This is where we're actually filling it up, this equal sign. But see, when I was saying there was 3 steps and I was trying to figure out in which order, well, technically, this gets executed first before it can be assigned. That makes sense? So technically, it's first you need to create an instance, then you need to have a variable for it, and then you can assign one inside the other. I mean, if you really logic it out. But at the same time, these two steps usually happen together, right? They're kind of same second, or millisecond. All right, let's play around a little bit. Oh no, I guess we're not done yet. A couple more information. So we're still talking about objects. Everybody understand that we gave a birth to a new object just a second ago by saying new?
For the creating the object, we are not using the primitive data type, right? Like
No, primitive data type, they don't need to be, no. Arrays are special, right? Because arrays, I mean, in Java, if you look at it, array, right? That's what the data type is, array. Has a capital A. That's how you know it's actually an object, or rather, yeah, an object.
We can create like that, but we're just only the first letters will be like that.
Yeah, for everything that's lowercase, you don't have to do that. Array is kind of a weird beast. That's why, like, remember when we were declaring array, you can say like new and you can say square brackets 10, right? And so it's the only one that's not weird. Like it's, essentially you're saying new array, but it's a shortcut. So you can leave out the word array. Or you can put it in, but nobody ever does. So I don't know, it's weird. Okay, last thing to remember. Instantiating. Whatever, if I say it wrong, just pretend I said it right. Instantiating a bicycle object, and this bicycle object takes some inputs in, right? A 5 and a color, right? 5 being the speed and the color. So far, so good? And then we are initializing what? Our variable bike, the bike variable, right? So far, so good. All right, good, good. What are we doing next? What's this line doing?
Printing out.
We are printing out, this bike is blue, and we are printing out, I mean, I kind of gave it away, right? I said 5 is the speed. So we're saying this bike is, I guess it should say this bike's speed is 5 miles per hour, right? So far, so good? So this bike, again, this is not a real world, right? Coding world. In the coding world, you create an object with already speeding down the road, right? It's already going 5 miles an hour. All right, so far, so good. So here, see, we did it correctly. We want to actually change the object. All right, so we don't just want to print out what's inside it. We want to be able to change it. So far, so good? So, once again, we are creating a new instance of a bicycle, same as the last page, and we are storing it inside the variable, right? But this time around, there are 2 more functions. We don't know how they work yet. We're actually going to implement them right now together. But from the name, can we guess what they do? What does this function do? Accelerate. It increases the speed, right? And what do you think this function does?
Makes the speed to 0.
There you go. Exactly. So far, so good? So this is an example of self-documenting code. I didn't have to tell you what those functions do. You were able to say without me actually uttering a word, right? Make sense? All right, let's implement them. Well, hold on, let me see what's next. Let's do the next few PowerPoints. What time is it? 8:35. Yeah, let's do the last one, and then we'll implement it after the break. How does that sound? All right. So hopefully, like, we'll come back and you have a fresh head, and you help me implement it on the board, right? Yeah. Okay. So. Oh, I guess we don't have PowerPoint for it. Weird. Okay. I'll just talk you through it. Eraser. Okay, functions. We're going to talk about how to create a class later. for now, let's just talk about functions. There's no really special keyword in Java when you want to declare a function. Like I said, the only difference between a variable and a function is that there's parentheses or no parentheses. That's how Java can tell. I know in other languages you will put things like function. If you're in JavaScript, you would actually say function. Or if in your Python, you would say like def, right? But in Java, there's not. If you want to create a function, just go for it. No preamble required. But you do have to immediately, when you're declaring a function, or not declaring, defining a function, when you're defining a function, you immediately do have to specify, is it going to be publicly accessible or not? And immediately you have to specify, will it return any kind of data or not, right? So if we have a function such as accelerate, right? We have to decide, is it going to be returning anything? Will it return a value? And that's already kind of, that's up to us, the designers. For now, let's put void, and later on we'll see if that's correct assumption or not. But usually when I start to define a function, I always put void, and then later on, if I figure out that needs to return something, I can always change it. Does that make sense? Now, first things first, if we ever want any code that is outside the file where we're creating the code, to be able to access that function, to be able to use it, to call it, it needs to be either public or protected. It can't be private. Immediate, out of the box. All right? So let's go with public for now. And if later on we decide that we want a little less scope, we can always change it to protected. Make sense? So we're gonna say public. Oh, no, I wrote it correctly. Public. And then we decided it was gonna be void, just because for now, we don't know whether it needs to return anything, right? And then we're gonna say the name of our function. So function. So far, so good? And then you put a set of parentheses. This is what the header for a function looks like when you're trying to define it. Now, once you define a header, you put a set of curly brackets. And different people have different preferences how they put their curly brackets. Some people like to have an opening one here and the closing one right under it. My personal preference is just to have it at the end of my header and then to have the closing one under it. No right or wrong. Usually your team will have a set of kind of guidelines about how they structure or style their code. And that's what you're gonna look at, all right? And each team has its own. Sometimes they like it this way, sometimes they like it that way. It is what it is. Now, regardless of how you style it this way or that way, the code inside will be indented. All right? Just again, for ease of reading. Now, why do you think I like to have it this way?
Consistency.
Not really consistency. I like to be able to see, like if I have a closing bracket, I like to be able to see immediately what it closes. All right? But lots of times, if I do something like this, I can maybe like erase it for some reason, like accidentally, or I might have another if statement somewhere in there or a for loop, and I forgot to indent it, and then I'll be confused what it belongs to. So that's why I like to have my opening parentheses at the end, so I can't confuse, where it belongs to. But it's just, again, personal preference. I actually need those, but anyways. By the way, I know my curly brackets look really weird. They get weirder and weirder every single time I teach a class. Okay, so what goes in the parentheses? Well, we're not talking about with those specifically exactly right now. We're just talking in general. I'm defining a function. What goes inside the function?
Acceleration.
We're not talking about acceleration specifically right now, just any function. Any function. What usually goes inside the parentheses? Some type of value, some type of data, right? Not all functions require data. Not all of them. You could have a function that takes nothing. They're just empty, like they are right now. If your function does require data, it has to specify what kind of data. You can't just be like A, comma, B. No, can't do that. You have to specify what is the data type of A, what is the data type of B. right? So if A is going to be a word, you have to say string A, right? If B is going to be a number, you have to specify what type of number, int or double or whatever it's going to be. So far so good? That's it. That's all there is to it. Now, because we said void, we don't need to return anything. But what if I actually wanted to return something? What if I wanted to return a number? What would I do? Let's stick with int, it's easier. But what if I wanted to return an int? What would I do? I would put int here instead of void, right? And then I would have to say return and then some kind of number, right? So for example, if I have int b, maybe I want to return int b. Okay, that makes no sense. You're putting it in and then you're spitting it back out, but for the sake of argument, does that make sense? Or maybe I want to do something like this, b times 2. That makes a little more sense. All right? Cool? So it's pretty easy, right? Nothing like, woo! All right, guess what time it is? Break time. So it's 10 minutes to. Please be back by 9:10.